Welcome back. This is John P. Kelleher from Los Monos College. I'm talking about fire chemistry and behavior. This is week 2. As you can see, I go pretty fast. If you need to stop, just pause it, write down a question, and I'll cover it. You can contact me and we'll go over it together. Okay? But again, this is just to supplement your PowerPoint on your Canvas. So week 2, here we go. Fire chemistry and physics of fire. The universe is made up of substance referred to as matter. Matter is something that occupies space and can be perceived by one or more senses. Matter is never destroyed, although it may change its form. Example is iron. It will rust, allow oxidation of substance, and deteriorate in dust after several years. Matter has 3 forms: liquid, gas, and a solid. All living things are made up of millions of cells. The cells are made of compounds, which are made up of molecules. Molecules are a chemical combination of atoms from 2 or more elements. Atoms are made up of smaller particles known as electrons, protons, and neutrons. The nucleus, or the center of the atom, is made of a neutron and protons. The electrons orbit and rotate around the nucleus, and atoms that lack electrons will be quick to link up to form molecules. And the atom is stable and has a good balance. Again, there's handouts I've given to you on Canvas, one of them being about metric system equivalence, which you'll see on Canvas. Now we're going to be going over, we talk about measurements, and this one is metric system equivalence. So know about that. Continue on. Substances that are or were once living is referred to as organic. Organic substances generally contain carbon, hydrogen, and oxygen in their composition. A non-living substance can be considered organic if it's made up of chemicals that were at some point living or alive. An example of that is like plastics, like PVC piping. PVC piping is made up of oils known as hydrocarbons. These oils are the remains of prehistoric living organisms. For the most part, most organic materials will burn, and there are a few exceptions though. There are some substances that are non-living. They're referred to as inorganic substances. Minerals are examples of inorganic substances. Chemicals are made of a combination of molecules. They are joined together and are separated by bonding actions that are used a form of electricity as energy. An example is water. It's made up of hydrogen and oxygen molecules. Water is composed of 2 parts hydrogen molecules and 1 part oxygen, hence H2O. The combination and separation of these molecules and atoms provide the basis for what causes oxidation and combustion. Again, I referred about atoms and how their makeup, the smaller particles and such. The term bond is the atomic glue that holds molecules together. It is this bond that fire or combustion has its origins. When molecules join, heat is absorbed. This is known as an endothermic reaction. Endothermic reaction. When bonds break, heat is released. This is known as an exothermic reaction. Endo being absorbed, going in, exo mean exiting, being released. So know the difference between endothermic and exothermic reaction. If the release of heat is rapid and continuous, fire and heat is generated. The ability to recognize a chemical compound will help the firefighter identify which type of extinguisher to use. We'll go over that later when we talk about fire extinguishers. An oxidizer acts as a catalyst in the breakdown of stable molecules. An oxidizer possesses a chemical property that can pull apart a molecule and break apart that bond that originally existed. If this oxidation process continues through a self-sustained chemical reaction, combustion will occur. An example of that is fire, the rapid oxidation of a substance. If the oxidation process is slow, a gradual deterioration of the material will occur over time. Example is rust, the slow oxidation of substance, where fire is the complete opposite, is a rapid oxidation of the substance. Remember, though, that the oxidation process is much more evident during combustion or in an active fire. Sources of heat. Heat is the energy source that powers the universe. Heat can neither be created nor destroyed. Heat is the physical manifestation of energy as it changes from one form to another. Heat comes from four basic components: chemical, electrical, mechanical, and nuclear. We'll go over chemical. Number one, the most common source of heat that firefighters deal with most often is the chemical reaction that releases heat as a byproduct. Anything that burns does through a chemical reaction in which heat is released as the bonds of the molecules break down. One of my favorite words, pyrolysis. Pyrolysis is the decomposition or transformation of a compound caused by heat. Number two, mechanical. Mechanical friction causes heat that can reach levels hot enough to ignite any surrounding combustible material. An example is rubbing two sticks together. They can ignite due to friction. The buildup of heat from friction is often the cause of fire in machinery. The third type of basic source of heat is electrical. Electricity is the most recognized source of heat. An electrical current can generate heat. Electricity is simply the flow of electrons from an area where there are too many electrons to an area where there are not enough electrons. The place where electrons are in large quantities is referred to as being negatively charged. Conversely, the place where electrons are lacking is referred to as a positively charged. Third component, electrical. Electrons travel through a conductor to reach their destination. Example, a wire, metal, or even water. They're good conductors, they say, conductance. Depending on the density of the conductor and the insulation surrounding it, the heat generated by the transfer varies greatly. The heavier the material, the more efficient it is as a conductor. When the electrical flow occurs, one electron jumps into an odd atom, which releases another to move into the next atom. Collisions of electrons send them astray and collide with molecules. The molecular compound is broken, which releases heat, which we also consider exothermic reaction. Firefighters must respect the forms of electrical energy and how effective it is as a heat source. And lastly, number four, nuclear. Nuclear energy generates heat the same way as do other forms of energy. Radioactive materials are very unstable and are constantly breaking down as they seek to form more stable molecules. There's little firefighters can do as a nuclear fire incident. Best way to remove the heat source or oxygen and break up the force side of that fire tetrahedron is that chemical chain reaction. Nuclear energy is created by the radioactive materials. They are encased in lead formed by rods and then submerged into water. The heat transfers the water into steam, which then turns turbines that generate electricity. And that's how we get nuclear energy. Next part, combustion. Combustion is often confused with the term fire. Fire is a chemical reaction that is a self-sustaining process that emits light and heat and as a byproduct of that reaction. In combustion, the release of heat energy is reinvested in the process, causing the continued reaction to occur repeatedly. It is the continued release of heat energy in the chain reaction process occurs repeatedly. If combustion is not controlled and there's access to heat, fuel, and or oxygen, triangle, the growth will accelerate. Oxygen and its effects on combustion. The Earth's atmosphere contains about 21% oxygen, 78% nitrogen, and 1% inert gases. So when we take a normal breath of air, 21% oxygen, 78% nitrogen, and a little less than 1% of inert gases. Oxygen acts as a catalyst to the combustion process. Oxygen is the technical term used to describe a chain reaction. The presence of oxygen can affect a material's combustibility. The higher the concentration of oxygen, it can cause some materials to ignite spontaneously or permit materials to burn that would not normally burn at a regular oxygen level concentration. An example of that is like blowing on a fire. It gets the fire get going more. Okay, that concludes week 2. Thank you.